Welcome to Brain Vision.
In this question, there are three forces acting on the car: the weight force, the normal force, and the frictional force. We will begin this question by calculating the value of the normal force. So how can we do that? We do that by decomposing the weight force in two components. One component is this one, let me call it Wy, and the other component is that one, let me call it Wx. Now we can choose our reference frame as follows. So this axis will be the y-axis and this other axis will be the x-axis. So everything that is pointing in this direction is positive or negative. Then we apply Newton's second law over that y-axis. So over that axis, we have that the net force is equals to the mass of the car times the acceleration on that axis. Note that the car is either going in this direction or in that direction, so it doesn't move in this axis. Therefore, the acceleration on that axis is equals to 0. And the net force is composed by two forces, the normal force and Wy, one of the components of the weight force, and this is equals to 0. Therefore, the normal force is equals to the y component of the weight force. Now, what is the y component of the weight force? To figure it out, we have to do a little bit of geometry. So this angle is 15 degrees. If we extend the weight W until it reaches this point, we see a rectangle triangle arising. This angle is 90 degrees, and this angle is, as a consequence, 75 degrees, because this angle plus this angle must be equals to 90 degrees. At the same time, note that this angle here is a right angle, so 75 degrees plus some unknown angle must be equals to 90 degrees. And we know that 75 plus 15 is equals to 90 degrees. So this angle is an angle of 15 degrees. Now we can calculate the cosine of 15 degrees using the definition of the cosine. So the cosine of 15 degrees is equals to the adjacent side, Wy, divided by the hypotenuse, which is equals to W. Therefore, Wy is equals to W times the cosine of 15 degrees. Finally, the normal force is given by the weight force times the cosine of 15 degrees. But the weight force is equals to the following: the mass of the car times the acceleration of gravity, and then we have that cosine of 15 degrees. In this question, the mass of the car is equals to 1,700 kilograms, and the acceleration of gravity is approximately 9.8 meters per second squared. Therefore, the normal force is equals to 1,700 times 9.8 times the cosine of 15 degrees. And this gives us approximately 16,000 newtons. So this is the normal force. Now, we have to calculate what is the frictional force. To do that, we apply Newton's second law on the x-axis. So on that axis, the net force is equals to the mass times the acceleration on that axis. Note that the car is parked, therefore it isn't moving and it's not going to move. So the acceleration on that axis is equals to 0 too. But the net force is composed by two forces: the weight force component x and the frictional force. This is equals to 0. Therefore, the frictional force is equals to the x component of the weight force. By using a similar reasoning that we had already used, we can calculate what is the x component of the weight force. We have to do that, we have to calculate the sine of 15 degrees. The sine is equals to opposite side of the triangle, which is Wx, divided by the hypotenuse. Therefore, Wx is equals to W times the sine of 15 degrees. Therefore, the frictional force that is acting is equals to the weight force times the sine of 15 degrees. Using the information we already had, we have that the frictional force is equals to 1700 times 9.8 times the sine of 15 degrees. And this gives us a frictional force of approximately 4,300 newtons. So this is the frictional force, and this is the normal force that is acting on our car.